So hi everyone, Chen Hao over here, and today we'll be continuing with Intro to Python Coding, Lecture 2, Functions and Conditionals. So we'll be going through these two, and we'll be seeing that with these two we are actually able to achieve much more functionality as compared to just having variables, lists and for loops. Okay, so in addition to that, we'll also be going through some user input where you can interact with the user. So you ask the user for like to input a number, and then you can process the user input in whatever way you want and output something. So perhaps you can build something like a calculator, or yeah, some really simple program to like calculate your BMI and so on. Okay, so without further ado, okay, before that, right, I'll be going through the exercises I left y'all in the previous lesson. The first two exercises are a bit different from the 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 one you see in the previous video, because I actually edited them when I realized that I didn't teach user input in the first video. So, but let's just go through these questions. You can go ahead and, if you're watching the video, you can go ahead and jump to a certain timestamp. Yeah, to start with functions. Or if you want to, but if you want to check whether your answer is correct, then yeah, you can stay on. So first of all, let's try to tackle the first question. Write a code to calculate the sum from 1 to 100. So that basically means calculate 1 plus 2 plus 3 plus 4 so on to 100. Right? So how do we achieve that? So so we can create a variable. Let's call it s. Right? I want to call it sum, but then actually sum is a keyword, so let's avoid that. So basically sum represents something else in Python, so it represents a function. So let's just use the word s to abbreviate it. So let's just initiate to 0 to say that the current sum is 0. So this is a variable to keep track of the sum. Okay, so then we need to, let's incrementally increase this sum variable to add up all the numbers. So in order to generate all numbers from 0 to 100, we can use the for loop, learned in the previous lesson, this, right, for I in range 0 to 100. So if we print I, we see that this is going to give us 0. There's 100 iterations, and for each iteration I is going to increment by 1. So the first iteration I takes on the value 0, next one I takes on the value 1, and so on until 99. So but note that we don't want the sum from 0 to 99, right? We want a sum from 0 to 1. We want a sum from 1 to 100. So we can just add a plus 1 over here to make, so now I plus 1 will take on values. Wait, okay, I need to clear the screen whenever I run the code, because it doesn't clear the previous output. Yeah, so now the first number is now 1. It first prints 1, so and until 100. So now I plus 1 is the kind of is the value that we want to add up. So in order to sum it all up, we can just say s equals to s plus I plus 1. So basically what this is saying is that for each iteration, we take we set a new value to the sum variable, and what is the new value? It is the current sum plus I plus 1. So what this looks like is that in the first iteration, when I equals to 0, then you have s equals to s, which is currently 0, plus I plus 1, which is going to be 1. Okay, then in the next iteration, when I equals to 1, then s equals to the current sum, which is 1, plus I plus 1, which is going to be 2, right? So that gives you 3. And the next iteration, I equals to 2, s would then be set to equals to 3 plus the current I plus 1, which is 3, equals to 6. And this continues so on until 100 times. So at the end of it, we can just print s. So the sum is s. And we run enter. You see that the sum is 5050, and that is indeed the sum from 1 to 100. So that's the first exercise. Okay, so yeah, so let's take a look at the second exercise. Write a code to negate all numbers in a list. So how do you do that? So let's say we have a list, right? I'll just call it L, and let's say as 1 2 3 4 1 2 minus 5 minus 3. Okay, so how do I negate all the numbers in the list? So in order to negate the numbers in the list, we need to iterate through the list first. So how do you iterate through a list again? How do you access all the elements in the list? You go by the indexing. So for example, to access the first element, you go by L, and then you put these square brackets, and then you put in the index that you access, which is index 0, which corresponds to the first element. So right now this is going to be 1. Yeah, so how you can also edit the list elements by putting this. It's kind of acts like a variable, and you put an equal sign and you put the new value that you want. You print L after that, you're gonna get 5 in the first slot instead of 1. Alright, so that's just a quick recap of how this works. So how do you negate all the numbers in the list? So we first need to access the elements in the list, right? So for I in range, so we want the length of the list, and yeah, so now if you print I, right, you're gonna see that current is I is the index from 0 to 7, which makes sense because there are a total of 8 elements in this list. So if you go ahead and put print of L in index I, then we're gonna see basically all the elements in our list. But we don't want to just print it out, we want to change the value of it, right? So how do we do that? So we set L index I equals to, now we want the negative, we want to negate the number, meaning that for the first slot we want it to become -1, for the second one we want it to become -2, -3, -4, -1, -2, 5, and 3. So how do we do that? We can do this. So yeah, so we set, so what this is saying is that for each index I, right, you want to set the value of the ith index to be equal to something new, and the something new is minus of the current value. So the first Li over here, I mean the second Li over here on the right hand side, we're assessing the value, right? You're kind of querying for the value. It's asking the list L, hey, what is your value at I? Okay, and then this would give you this will return some number. For example, L of 0 at index 0, this will become 1 on the right. You return the value 1, and then you're saying that, okay, now I have the value 1, right? Negate it, so now it's -1, right? -1 on the right hand side, and then I'm saying now this new value -1, I want you to put it into the variable L of I, which is the ith index of the list L. So yeah, remember what I talked previously about how when you write things like x equals to x plus 10, right? Let's say you write x equals to 1, x equals to x plus 10. This is the right hand side is a new value that you want to assign using equal sign to the old variable x. So this is not asking you to solve for the equality in coding. Is not asking you to solve for an equation. It's asking you to assign the right hand side to the variable on the left hand side. Okay, so once again, this does not mean that you cannot say like, oh, solving this you get L of I equals 0, because that's not how the equality sign in coding works. The equality sign in coding is an assignment, right? Okay, so anyway, enough blabbering. Let's try to recap some old concepts. So if we go ahead and clear the screen and run the code, we see that print of L now has successfully negated all the elements in the list. So that is how you do question 2, write code to negate all the numbers in the list. Now let's do question 3, write code to reverse a list. Okay, so let's use the same list over here, and let's see how we can reverse it. Okay, let's just use a variable r to denote the reversed list. At the moment it's empty. Okay, so how do we reverse the list? Well, what does it mean to reverse a list? That means that the last element, right, becomes the first element, second last element becomes the second element, and so on. So how can we achieve that? So we can achieve that using the append, right? So currently the r, we want to achieve the task of like r.append -3, r.append -5, r.append 2, and so on, right? And so on. But but we cannot, we shouldn't, this is a bad way of doing it, because then if I want to change, let's say this -3 to -2, then it does not automatically, you cannot, the resultant R won't be automatically the reversal, right? Basically I don't want to do it manually. So how I can automate the process is using for loops. So we first need to access all the elements, right? So what might that look like? Okay, so remember that if you want to access the last element, you do print the list name, and then you put the square brackets, and sandwich between the square brackets is the minus the nth element that you want to access. So if I do L -1 recap, you're gonna get the last element, which is -2. So so essentially the behavior that I'm trying to achieve is going to be r.append -1, r.append -2, r.append -3, and so on. Okay, and this continues until r.append minus length of the list. Okay, so length of the list in this case would be 8. So how do we achieve that? So first of all, we know that we can use the length function to capture the length of the list. So if I print length of L, I'm gonna get 8. So let's go ahead and write a for loop with that. For I in range this, yeah. So for I in range that, let's go ahead and print I. Oh, I forgot to write in. For I in range that, let's go ahead and print I. So it sees that it goes from 0 to 7. But so if we put +1 over here, then you can see that it goes from 1 to 8. Okay, which is, and we put brackets around this and write minus, then it's going to print this value, okay, which is going to be -1 to -8. So you can see that now we kind of found a way to iterate through the list backwards. So if I'll put L over here, then you see that I have now found a way to iterate through the list backwards. So you see, when I goes to 1, when I goes to 0, I've accessed the last element, and when I goes to 1, I access the second last element, and so on. So let's go ahead. So now that we've kind of kept this value represents the list, going through the list one by one from the back, then all I need to do is write r.append this value, and yeah, and so what this means is that for each of these values, -2, -5, 2, and so on, I'm going to add it to the back of R. So what this will look like is the print R after the for loop. Remember that there's no indentation for this print statement because it's not captured within the for loop. Then I'm going to get the successful reversal of the original list. Okay, so let me just say that if I do something, I put a tab over here, then now this print R statement is within this for loop, right? And what would that look like? Okay, what would that look like? It will look like this. So after you appended the first guy, then it's going to be -2. And you see that the list is slowly growing as I go down, as I iterate through the for loop. Yeah. So that's just a small difference between whether you put indentation here or not. Okay. So yeah. Okay, so that's task 3. Okay, so the last task, okay, the last task requires some user input. I forgot to kind of remove that, but anyway, write code to take in an integer n, take in n strings and store them in a list. So how would that look like? So we write n equals input. Okay, actually this is kind of what we're going to cover in this lesson, so let's go ahead and skip that for now. In the actual slides, I'm going to remove this then. Yeah, okay, so yeah, so okay, now we've covered all the questions. Let's go ahead and start with the functions. So functions in Python actually behave quite similarly to functions in math, in the sense that they take in some input parameters and they may or may not return an output. So we'll see okay, that's where it differs from math. From math, right, it will definitely return an output, right? If not, the function is kind of useless. But in coding, your function can perform some tasks, maybe print out some stuff to screen, but not return an output. And we'll see more of that later. Okay, before that, let me just drink a bit of water. Okay, so how to define a function? So you define a function using the def keyword, right? And then you write the name of the function, bracket, and you put a bracket, round brackets, and inside the brackets you put in whatever parameters you want to take in. So this will be a variable, x will become a variable basically, and then you put colon, and then you go to the next line, you put a tab, you put a space over here, and then from then on it's similar to a for loop in that you will execute whatever's in the block of code in the function. So for example, if we want to define a function called square this number, so I'll write df to tell Python that I'm writing a function, and I write square this number. This is the name of the function. So now I'll open this round brackets, and inside the round brackets I'll put in whatever parameters I'm taking in, right? In this case, I can take as many parameters as I want, x, y, z, blah, and so on. But in this case, let's just take in one variable, x, right? And then I'll write colon to tell Python that whatever's in this block of code, right, is whatever's indented within this block of code. Remember, the indentation is this space over here. Whatever's in this indentation is going to represent what I want to write in the function. So in this case, let's write print x times x. Okay, so x is a variable, right? You pass in the variable into the function, and the function performs some task, which is namely print x times x. So what might this look like? So if I call the function square this number, and I pass in the variable 3, yeah, let's go ahead and print this. So I'm going to get 9. Okay, sorry, I should not print it. Wait, sorry, I should not print it. So I cross square this number, I'm going to get upward of 9. So what is happening over here is that when I call, okay, so remember I said that Python goes sequentially, right? So it looks at the first line, it defines a function, and then second line is within the block, so it says, okay, this is part of the function. Then the third line is blank, you ignore it. Then the fourth line is going to see, okay, I want to call the function. When you type the name of the function, you're calling the function. So this tells Python, I want to call the function square this number, and I want to pass in a variable 3. So what Python will do is it will look up in its bunch of database of functions, and you're going to say, do I have this function name, square this number? And yes, I do have the function name. And then you pass in the parameter 3, and this function is waiting to eat an input. In this case, the input is the variable x equals to 3, right? And this 3 is going to go in, and now x has the value 3. So when I do this, when I call this, then x is the value 3. So x is a variable that stores the value 3. And then in the next line, it says print x times x. So what it means is that it's going to print x times x, which in this case is print of 9, right? And that's precisely what we see as the output, right? So but this does not mean that x has a fixed value of 3, because if I call this function with a different parameter, square this number, let's say 5, then x is going to take on a new value. It's going to take in 5. So if I run this code, right, it's still going to execute the line 4, because I have this line which is going to output 9, but it's also going to execute line 5, which is 25, which will output 25, which is 5 times 5, right? And so on. So I can call this with any number I like with x as the parameter. Yeah, so this x equals to over here is optional. You can add it in or you cannot. Yeah, it doesn't affect it. So okay, so function names also follow the similar rules to variable names, in that it's case sensitive. If I capitalize the n over here, and I define this function called square this number with a capital N, and I try to call square this number without a capital N, then Python is going to complain. It's going to say, hey, I'm looking for a function with the name of square this number, but it's not defined because Python names and for Python variable names and function names are case sensitive. So this must be a lower end, must match it completely. These two must match completely. Okay. So yeah. So that's for functions. That's the introduction to functions. So functions can do other stuff also. It can, for example, you can define more complicated behavior. For example, I want to create a function that creates a list, right? And it takes in a variable which I call size. Remember that this variable can be called anything. So what might this function do? It will create, let's say I define it to behave like this. So I define an empty list. Then for I in range size, then so we're having a for loop within a function, which means that there'll be one more additional layer of indentation, and I can write my list dot append I. So if I print my list after that, and let's see so we have defined this function, but let's see what the behavior of it is. So if I make a list with 3 passed in as a size, so right, then size will take on the value 3, right? The variable size in this function will now would have the value 3. So it goes through this, it creates an empty list, and for I in range size, so it's effectively for I in range 3, it's going to append to the list a bunch of numbers, and the number is going to be I, and after that after doing the for loop, you exit the for loop, then you're going to print the my list, and we see that if we pass in make a list with the parameter size equals to 3, then it creates a list with size 3. So yeah, so I can easily duplicate this line. I can call the same function again with a different parameter, right? In this case, I send in a parameter size equals to 10, and then the next line, let's say I send in size equals to 25, and run this. You see that it first generates a size of list 3, right? 0, 1, 2. Then it generates a list of size 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then lastly, it generates a list of size 25, 0 to 24. You can see. So you can see that functions are a way to functions together with for loops, they can now achieve many things. Previously, if you wanted to create 3 lists of different sizes, perhaps you need to write like for I in range, right? Perhaps you need to write for I in range 3, then you create this, then the next line you need to create this, and then next line you need to create this, and then you need to change it, say 10, and this 25. But in this case, if you have repeated code like that, you can kind of put it into a function, right? And then after that, you can just, instead of writing all this bunch of code, instead of writing all that code, you can just call the function with a different parameter. Yeah, and it's important to note that when I call the function with parameter 3, it does not permanently set the parameter to equal to 3, because when I call another function with a different parameter, the function will essentially, it never knew that it was, yeah, but what I'm trying to say is that these calls are independent of one another, right? You call it once, then it kind of forgets that everything ever happened, then you call it another time, and so on. Yeah, so okay, so besides just printing out lists, right, what can functions do? Functions can actually return a value. So if I use the keyword return, right, what it essentially does is, let me see if I have annotations. Okay, I don't. So what a function can do is it can also return a value. So let's say I have a function called my function, and it takes in a parameter a, right? So a will be the variable, and let's say it returns a times 3. So this basically, there's no better way to describe it. Kind of, you pass in a value to the function stored in the variable a, then it's going to return you the value of whatever's here. So in this case, returns a times 3. So if I do something like print my function and I pass in 2, right, then what's going to happen is, if I execute it, you see it prints 6. So what actually happens here is, sorry, let me drink water. Oh, my sore throat is quite bad. Okay, so what actually happens here is that, So the 2 gets passed in as a value to the variable a, right, as a parameter. So a equals to 2, then it returns 2 times 3, which returns 6. So after that, essentially is replacing this, my function 2 over here, with the value 6, because the function has returned you a value. So that's why we see 6. So you may be wondering now, why can't I just say, instead of doing that, why can't I just say print a times 3, right? Wouldn't that achieve the same result? And if I just call function 2 like that, right, wouldn't that achieve the same result? And you would be right. Yeah, you see that it does achieve the same result, but there's some value in returning something, because if you return something, you see that you can store it in a variable, right? Because if you return something, store return value into a variable, so you can write x equals to my function 20, and then after that you can do whatever you want with x. So as compared to just printing whatever, doing the print statement in the function, right? If you want to do more stuff with the whatever return value there is, then that's the purpose of return. So you see that in this case, this code snippet on the left here generates the output on the right. So print my function 2, just print 6, print my function 5, just print 5 times 3 is 15. So then, but in the next line, the value added to using a return keyword is that you can store the whatever value the function returned into a variable. So if you call x equals to my function 20, 20 gets passed in as a variable, right? And it returns 20 times 3, and so the function, my function over here is replaced by, it returns 60. So it's x, this line of code becomes x equals to 60. So if you print x, right, and you see it prints 60, right? But then from then on, the variable has the value 60, and you can do whatever you want with it, right? X equals to x plus 10, and you're going to see that x is now 70, and so on. And one additional thing that you can also do is you can pass the output of one function into the input of another function. So for example, print my function 10. So there's 2 calls to my function here. This might seem familiar in math, right? If you apply f of f, right? So my function 10 is going to return 30, right? And then, so it's going to be 30 on the first call, right? So what I'm trying to say is that if I do this, my function 10, my function 10, okay, I'm missing a bracket. So if I do my function 10, it's going to print 90, because the first call here, right, my function 10 is going to return the value 30. Then this 30 is passed in as a variable, is passed in as a parameter into my function again, and this is going to return 90, right? So yeah, so that's why you can do stuff like that if you do using the return keyword. You can also define multiple functions. So for example, I can define a square function that returns the parameter squared, right? I can define an add1 function which returns the parameter plus 1, and then I can have functions called functions as well. So in this case, if we print square of 3, right, it's just going to print 9. We print add1 of 10, it's going to print 11, right? But if I print weird of 2, so what does that do? Let's take a look. So over here, we call the weird function with a parameter a equals to 2. In the next line, we create a new variable x, and we set it to the value of square of a, which is square of 2. So that's going to be x equals to 4, right? And then in the next line of code, we set x equals to add 1 of x. So x is currently 4. It calls the variable, it calls the function add1, which returns 4 plus 1, which is 5. And after that, we return 5. So that's why we see, and it print 5, that's why we see the output as 5. So yeah, so that's a crash course on functions. Sorry, my throat is really quite bad now, but I'll just continue. So yeah, so next thing we can do is how to add logic to the program. Currently we just have a way of doing stuff iteratively, right? We have functions that can help us automate certain processes, and yeah, but how do we use conditionals to add logic, right? That redirect the flow of our program. So that's what conditions are for. But before that, let's do a quick crash course on user input. So if I have, let's say, animal, I create a variable called animal, and I want to set it to whatever the user inputs, right? So I can do input, and then the message I pass in here is going to be whatever is going to prompt the user for doing so. So like, for example, I say, what is your favorite animal, right? And if I do that and I press run, then the console is going to ask me, it's going to write whatever is in the function first, and then it's going to let me type something, right? So if I do this, then although there's no output, currently animal would store the value of my input, right? So that's what the input function does. It lets you interact with the user. So for example, after the user's input is stored in the variable animal, I can interact with the user. For example, hi, so let's say, and then I can just print animal. So yeah, so if I execute this, then you see, let's say that, so they ask me for the console now prompts me for my input, and then I can type whatever I want, and then after that it prints hi, and then it prints whatever value is stored in the animal, which is going to be the user's input. Okay, so what if I want to input integers? Because currently the problem is that if I try to ask for an integer, right? Ask for user input, and let's say I'll try and multiply by 2. So let's say I say, what is your favorite number, right? And I store it in this variable called animal, and I try to print the number times 2, or let's say times 10, right? What I'm gonna see is that if I run into a problem where, let's say I type 5, it's gonna print 5, but right now what's happening is that it's actually interpreting animal as a word, meaning that instead of animal being the value 5, it's actually instead of this, what the code is actually thinking is that it's actually this animal equals to 5 with the inverted commas. And what this inverted commas is telling Python to do is basically treat this as a word instead of a number, and that's not what we want. So in order to avoid that, we're gonna put an int around this, right, which is going to return the value of the integer. So this is actually under the topic data types, but I will not go too much into depth of it. Yeah. So if I put this int, right, and I sandwich whatever is inside in the round brackets, then that's going to mean that I'm taking in a user's number. So if I run this again and I do 5, it's going to see it successfully does 5 times 10, which is 50. So yeah, so okay, so you can also take in decimal places by using float. But yeah, so okay, onto conditionals. So if I want to redirect the flow of the program based on the user's input, then let's just say I write, let's say I have these 2 lines of code which takes in the user's input and stores it in the variable animal. Then after I print, I also write, and then the value of the variable, exclamation mark, right? So after that, after this line of code, you see that we have a if else over here. What this means is that if the animal, the user input, is equals to cat, and you see there's 2 equal sign here, I'll elaborate on that later, right? If the animal is equals to cat, then print, then you see that you start a new block over here, just like what we saw in the for loop. There's this space over here called the indentation, and whatever's between this and whatever's in this block of indentation is going to be executed if this condition holds true. So for example, if animal equals cat, then print meow, otherwise print not meow. So what might this look like? So then now, whether it prints meow or not meow, whether Python prints meow or not meow, is going to depend on the user's input. So if I type this in the code, okay, input fav animal, so print, So you like animals. Okay, so if animal equals to cat, print meow, else print not meow. So what this will look like is that if I type in cat, right, then it's going to execute whatever's in this block of indented code, which in this case is line 5, which is meow. But if it's not, if let's say I just type some gibberish here, then it's not going to execute this block, but instead it's going to execute this block. So what this looks like in the program is that the Python would go line by line, right? It will go from the first line asking for the input, second line outputting some stuff, third line is going to see this fourth line over here. This if animals with cat is going to Python is going to compare the value in the variable animal with whatever's on the right hand side. So it's going to compare the left hand side and the right hand side, and if they are equal, then it will enter this first indented block, which in this case is code to say print meow. Otherwise, it's going to, the else here tells Python that, okay, if this condition does not hold true, then execute whatever's in this other block of code. So you see that if the user's input is cat, then animal will store the value cat, and cat equals to cat, right? Compare those two words, they are equal, so it's gonna execute meow. It's gonna execute print meow, and that's why we see the output meow. Whereas if the user's input was not cat, right, then animal equals to cat is going to be false. So it's not going to execute whatever's in the first block of code, but instead it's going to execute whatever's in the else block of code, which is print not meow. So I hope that this if else, you can see that it kind of redirects the flow of the program. If depending on the user's input, is going to either redirect to this block of code, right, which you can do whatever you want in this block of code, or another block of code, which you can also do whatever you want inside there. So what if you want to chain multiple of these if else commands, right? Yeah, sure, you can using the if else. Besides if and else, you can use the Elif command. So for example, if animal equals to cat, print meow, right? Else if animal equals to dog, print wolf. Else if animal equals to turtle, print brr. Else print by, right? So depending on the user's input, right, you can see the 4 cases of user input over here, you can successfully redirect the code. So this, then another way of possibly doing this is to do something like that. So else, right, then you do another block of code. If animal equals to dog, then print wolf. Else, then another block of indentation. If animal equals to turtle, print brr. Else print by. This works just the same way too, but you can see that if you continue this at the rate you're going, if you want to chain 10 of these together, by the time you're on the 10th line, you'll be writing code like at this block, which is not very nice looking. So instead of doing that, Python helps you shorten this else if into a very nice elif command, which is seen in the slide over here. So yeah, so you can see that using this, so there's more stuff that you can do, right? So besides comparing words with words, you can also compare numbers together. So if a variable is a number, then you can compare it with another number using things like inequality signs and stuff. So in this case, you see enter integer between 1 and 10. If it's less than 1, then you do certain behavior. If it's greater than 10, then you do some behavior. Otherwise, you say you entered the number. So you can see, depending on the user input, right, we can do comparisons. The upshot of this slide is that we can do comparisons between numbers, just like how you do comparisons between numbers in math. Yeah. So you can also do logic operands. So if you want to check 2 or more conditions, for example, if number is greater than or equal to 1 or number less than or equal to 10, then instead of writing nested if statements like that, right, where you have one if within another if, which is not very good because you can result in very messy indentation and hard to read code. You can use the and keyword like this to to say that if this is true and this is true, right? So if I'm sure you're familiar with the with like logic operators, there's also there's more operators such as or there's not operators and so on. So there's all these are called conditionals, and there's a whole list of them. These are just some, right? And yeah, so let's try to guess the output of this code. I'll give you some time to pause the video and check it out now. Okay, so what happens over here? Let me try to use my pen to draw. Okay, so I don't think I can use my pen for some reason. Okay, actually I can. Yeah, so in this case we see the output is B and then C. So why is that so? So you see A equals to 2, B equals to 3, okay, so that's okay, that's fine. Then if A times B equals to 5, is greater than 5, so is that true? So A times B, so what is A times B? A times B equals to 6, right? So is 6 greater than 5? That is true. So you enter this block of code. Okay, so you completely forget that you completely ignore this part and you enter this block of code. Then from here, you see if A is less than 2. So is A less than 2? Is 2 less than 2? That is wrong. So right, you will ignore this block of code and go on to the next statement. So if B is greater than or equal to 3, so is 3 greater than or equals to 3? That is true. So it will execute this block of code. And in this case, it is print B. So that's why we see the first B over here. Then after that, we see if A minus B is less than 0. So 2 minus 3, is it less than 0? Well, that is true. So it prints C. Now notice there's a key, which is why we see C over here. Now notice that there's a key distinction, which is that we have if over here, then we have Elif, right? With if over here, then with Elif, and then with another if over here. In this case, when Python looks at the code going from one line to the next, right? When it looks at code going from this line to the next line, is going to, over here, the behavior of this block does not affect the behavior of this block, meaning that you have if, right, and then you have if a statement, then you have some blah 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 code, then you have elif, right, and if a statement, then you have some blah 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 code, and then you have else, and then you have some blah 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 code, and then whatever's happening in this block, right, you can do some other code over here, and you can always start a new block. Like these two if else state, they are completely separate, they do not interact, okay, in the sense that they just go sequentially, and yeah, they won't really, they're not together. Yeah, so that's the guessing of the output for this one. And now I want you to spend a few minutes trying to code a simple function to calculate the square root of the input. It might seem quite daunting at first, but I will show you how you can use the if else statements to actually achieve this. Okay, so you can pause the video. I'll be going through in 3, 2, 1. Okay, so actually how we can achieve this is using for loops and if statements. So okay, this might be the first time we are putting so many concepts together, so it might be a bit confusing at first, but I hope I can break it down for you. So first we create a variable called y, and we store in the variable y the value of the user's input. Okay, so then we create another variable x, which is going to represent our answer, which is hopefully at the end of this program is going to store the answer, which is square root of y. So then we go, since we can assume that y is less than 1000, we have a for loop over here that goes from I equals to 0 to 39, right? And then we have if I times I is less than or equal to y, x equals to I. So let's try to see what this code is saying. This code is saying that we incrementally try different values of the square root, right? We incrementally try different values of the square root. So if I equals to 0, is 0 times 0 less than y? If that is so, then x equals to 0. Then after that, if I equals to 1 and so on, if I equals to 1, then we incrementally try bigger and bigger values of the square root until and for each of the successful ones, we set the current answer equals to that value. And if it goes beyond that, right, if it goes beyond that, then it's going to, then this if statement is not going to hold true, and the current answer is not going to be set to that one. So what it means is that so what this means is that if we insert a few print statements in here, we see that we're trying different values, right? So we try I equals 0, 0 is less than 256, so the user input is 256, 0 less than 256, so we update x to equals to 0. Then we try 1, we update x, try 2, we update x, and so on, until we see that when we try I equals to 16, 256 less than equals to 256, we update x equals 16, but I equals to 16 is the last one that successfully updates the value of x. In other words, in this for loop, x will be set to 0, then x will be set equal to 1, x will be set equal to 2, so on until 16, but after 16, right, x is not going to be updated anymore. X is going to be not set to 17, right? It's going to ignore the other cases because the if statement fails. So from then on, right, x only has the value 16, which is correctly the square root of 16. And yeah, and actually this is achievable, the square root function is achievable with the square root function, just like that, if we import something from the math library. So what is the math library? It's basically a library where some other coders have implemented a bunch of functions for you to use easily in your program, so that you won't have to manually go through the effort of defining a square root function again. But in this case we decided to do it ourselves, and a library is basically some code that you can write to share with somebody else, and one day perhaps you'll be writing your own library too, right? So yeah, so this is just a side note. There's such a thing as libraries in Python, but that's for another video. Okay, so before the end of this video, I want to go through another question, which is the fizz buzz. So what is fizz buzz? It's a classic test given the coding interview, and the task is simple. Print numbers 1 to some number, right? And for each one of those, if the number is divisible by 3, print fizz. Otherwise, if it's divisible by 5, print buzz. And if it's a print fizz buzz if it's divisible by both 3 and 5. So the correct output would be something like this: 1, 2, fizz, right? Because 3 is divisible by 3. And then 4, then instead of printing 5, we write buzz because it's divisible by 5. Then 6 is divisible by 3, so we write fizz, and so on until we reach 14, then 15. For 15, instead of writing 15 or fizz or buzz alone, we write fizz buzz because it's divisible by both. So this seems simple enough with for loops and if else statements, but is there a trick, right? Actually, yes, I invite you to try yourself first, but yes, there is a common mistake, which is that some people might write, according to the description here, it seems like we can write for I in range, we write a for loop, right, ranging from 1 to 21. Then we might be able to just write if I divisible by 3, this divide sign is basically find the remainder, right? If I remainder 3 is equal to 0, means it's divisible by 3, then write fizz. Otherwise, if it's divisible by 5, print buzz. Otherwise, if it's divisible by both, print fizz buzz. Otherwise, print the integer. So it may seem quite innocently correct, but actually it's actually wrong, because remember that what happens when I is equal to 15? Then we see that we step through the code over here, then I divided by 3 is going to then 15 modulo 3, 15 remainder 3 is going to give you 0, right, which is going to print fizz, and after that it's going to ignore the rest of the elif, and else over here. This is just going to print fizz, which is why we see that in the place of 15 we see fizz but not fizz buzz. So this produces the wrong behavior because we have actually ordered the if else statements wrongly. So instead of putting 3, 5 and then 3 and 5, right? 3, 5, and then 15. We need to reorder the if else statements to do 15 first, and then 3, and then 5, because you see that in Python the logic is sequential, meaning that you go from top to bottom, right? So if you go from line 2, you go from line 2 and you check that it's true first, then in this if statement it's going to be kind of, if the 15 case where I goes to 15 is going to be trapped in this line 3, right, and not execute the further on. So this is actually a simple programming task that they give on interviews to really test if you understand the sequential logic in Python in encoding. So this is the correct code where you see that it produces the correct output, because if it's divisible by 15, then you print fizz bars first and then you ignore the rest, right? But if it's only divisible by 3, then you print fizz. If it's only divisible by 5, then you print bars. Then otherwise you just print a number. So yeah, without further ado, I think that's the end of the lesson. Yeah, so if you are keen in doing further learning by yourself, you can try out topics like recursion and prime numbers. And yeah, so if you want to try some exercises, you can try to code prime number checker, right? So for example, check if the number less than 1000 is prime. You can use the for loops and use some if else statements, as well as the remainder sign to check if things are divisible. Then you can also code a perfect number generator, which is basically sum of factors equals to itself. Or you can code a number guesser game, and also related to that, there's a topic called binary search, but that's a little bit more advanced. And basically with these four stuff, you can kind of start to code a game already, right? Because you can imagine that if you take user input, right? So for example, name equals to input, give me your name, right? And then you can say print hi name, and then we can say let's play a game, right? And then from there we can say like perhaps our game is NC16, so we can only allow people 16 and above to play it. So we say what is your age, right? So we converted to integer. We say if age is greater than 16, greater than equals to 16, print welcome to my game, right? Otherwise print bye bye, you're too young. And then from there, inside this if statement, we can have a function, right? So let's say we have a function called start game, right? And let's just pass in the age as a number, as a parameter. So we have defined a function start game, and then we have the parameter age as a variable. Then we can say the game, let's say it says I can guess your birthday, which is going to be print, so what is the birthday is going to be the current year, which is 2021 minus age, right? So you can see that we can start to really, with this, with variables, with lists, with lists and functions, you can really start to kind of create kind of interactive games already. So for example, I have a list of, let's say, friends equals to, and let's say your friends, yeah, stuff like that. So you can really start to explore and code of anything that you like, or you can just try these problems, and from there you can, yeah, the freedom is yours. So anyway, with that, let's just end off the video. Yeah, okay, so you can leave now, but I think I'll spend the remaining of the time going through these questions. So yeah, so 3, 2, 1. Okay, so I let's call a prime number checker, right? So what might that look like? So let's say the user input num equals to int. We first need to take in the user input a number. Okay, so if we run that, we see that they asked me for a number, let's say 12. Okay, so now we can, so with this number stored in the variable called num, we can, for I in range num, right? So okay, so we want to check factors 2 to the number, right? To the number -1. So this is going to generate an array with 2, 3, 4, and so on to number -1. Okay, so for each of these guys, if the number divided by I leaves a remainder of 0, then that means it's divisible. So okay, actually I have not, okay, so let's just create an answer first. Let's just, by default the answer is prime. Okay, actually we can use something called booleans, but yeah, let's just say that by default the answer is prime. Okay, so if it's divisible, then clearly the answer would no longer be that. So it's going to be answer equals to not prime. Otherwise don't do anything, because it's okay so far. So at the end of it, you just print your number is answer. Okay, so we run this code, we take a look at, so let's input a number. Let's input, let's say 2, right? And 2 is prime. If we output the correct answer, if we do, let's say 5 is also prime. But if we, let's say, do a number 6, then where does it fail? It fails because when iterating through this, it goes through I equals to 2, right? So I over here, then number divided by I, 6 divided by 2 leaves a remainder of 0. So this equality will hold true. So we execute whatever code is in here, which sets the answer to not prime. And as long as one of that occurs, the number is no longer prime, and hence our answer is going to store the value not prime. So that's how you can code a prime checker. You can go up to, let's say, I'm not sure if 1007 is a prime. It's not a prime. And I'm not sure of a huge prime. Prime biggest, prime less than 1000. Let's try 997. Okay, 997. You see that 997 is in fact prime. So that's the prime checker for you. Okay, so the next one is a perfect number generator. Okay, so let's define the function is perfect, right? And it takes in x. Okay, so x is the variable that we're going to check. So what does it mean for a number to be perfect? It means that all the factors are, the sum of them up is going to be equals to itself. So s equals to, let capital S equals denote the sum, the current sum. So for I, we want to first find all the factors. So for I in range s, for I in range 1 to s, right? If x is divisible by I, then we are going to s equals to s plus I. Okay, otherwise leave it alone. So so from here, return s equals to, yeah, let's return the sum. Okay, so then we can, so from here we can, let's say we do we check. Okay, let's rename our function to sum of factors, right? And we just take a footnote to ourselves that it excludes s. So it's sum of factors, let's say 5, right? So in this case it's probably going to be 1. Why does that not run? Does it run? Okay, that's a bit strange. I've encountered my first bug. I am not sure why it does not run. Let me just do some debugging. Doesn't print that either. Let's take that away. How come it doesn't run? That's a bit weird. Doesn't print. Let's comment that out and see whether it runs. Does not run. Okay, I think maybe why is my previous user there? Okay. Okay, I think my internet connectivity is bad. So let's go ahead and write that again. Sum of vectors okay, so I'm not sure what happened over there. I think my internet connectivity was bad, so so it kind of lagged out. So anyway, so print hi, so print sum of, I just want to check that my function works well. Sum of factors 5 is 0. Why is that so? S equals to s plus I, return, it should return 1, right? Because 5 is put into x, then oh sorry, this should be x. Yeah, that makes sense. Okay, I'm sorry for the dumb mistake. Yeah, but anyway, that's kind of an example of a bug. I must be quite rusty. Yeah, so anyway, so now we can easily get the sum of factors. Okay, so how do we generate all the perfect numbers? So for I in range, let's say 1 to 1000, if sum of factors I equals to I, then we output print I is perfect. Okay, so that will generate all the perfect numbers, and we see that we have generated the first 3 perfect numbers. So that's how to do this exercise. I'm sorry for the dumb bug over here. Yeah, so let's do a number guesser game. So for example, x equals to input your number, input secret number. Okay, so then after that we will do, so now x stores the secret value. So let's just, for I in range 100, print a blank line, because we want to hide the secret number from, let's say, our player, right? So so this prints a blank line. And after that, let's say we give the guy 10 tries. So for I in range 10, if so, guess equals to, we want to take the guesses input, so guess equals to the input. What's your guess? Okay, so if, and we are converted to an integer. Sorry, here I also need to convert to integer. So here I need to convert to integer. So if guess is equals to the correct guess, then print you won. Okay, else Elif guess is less than x, print guess higher, else print guess lower. So yeah, so that's a simple number guessing game. So input secret number. Let's say you ask your friend to come over here and they input a secret number, then you see what's your guess. So let's say my guess is 90, then it's gonna ask me to guess lower, because 90 is higher than x. So the first if statement fails, goes on to the next elif, also fails, and it goes on to else, which prints guess lower, right? Then let's say I guess 70, then it's going to tell me to guess higher, right? But if I guess 80, then it's going to say I won. So perhaps after you won, you want to say, you want to stop the you want to break out this loop, because if not, it's just going to keep on asking you your guess, right? So you can use a keyword called break, right, which basically breaks out the loop, and you'll see that if I get the correct answer, I try 90, try 1, okay, but if I get the correct answer, it's gonna stop the code execution. So the break basically breaks out the for loop immediately. And yeah, so yeah, I hope that you've enjoyed these lessons. Of course, these are not by all means not uh not not like completely does not completely cover all the concepts, but that's all I can do in an hour. Yeah, so if you did, please leave a like and subscribe. Have a nice day. Bye.